Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore India's ambitious leap into the thorium energy era, where a rare fuel source and next-generation nuclear technology could unlock safer, cleaner, and more self-reliant power. And if it delivers on its promise, it could redefine how India powers its future. Imagine a power plant that runs on a fuel we have plenty of, produces minimal dangerous waste, and is far safer than what we use today. Sounds too good to be true? Well, it's not science fiction anymore. Maharashtra is preparing to build India's first nuclear power plants that will run on thorium instead of the usual uranium. 2 plants are being planned, one generating 1,540 megawatts and another producing 440 megawatts. These could eventually supply electricity at just 3.5 rupees per unit, making power more affordable while keeping our environment clean. This isn't just another construction project. It's a glimpse into how India might power itself in the coming decades. So what exactly is thorium, and why should we care? Thorium is a silvery metal found naturally in the Earth's soil and rocks. It's mildly radioactive, meaning it gives off small amounts of radiation, just like many elements around us do naturally. India is blessed with massive thorium deposits, mainly along the coastal sands of Kerala and Odisha. Nuclear power works by splitting certain materials apart, releasing tremendous energy that heats water into steam, which spins turbines to generate electricity. Most plants worldwide use uranium for this. But thorium can do the job too, though in a slightly different way. Here's the catch. Thorium doesn't split easily on its own. Inside a reactor, when thorium absorbs tiny particles called neutrons, it gradually transforms into uranium-233, which then splits to release energy. Think of thorium as a seed that needs nurturing before it can grow into a powerful energy source. Now comes the exciting part. Why is thorium better than uranium? The advantages are compelling. First, safety. Many thorium reactor designs work at normal atmospheric pressure, unlike uranium reactors that operate under intense pressure. If something malfunctions in a thorium reactor, it naturally cools down without needing emergency human action. The risk of catastrophic accidents drops dramatically. Uranium reactors need complex safety systems precisely because of those high pressures. Then there's nuclear waste. Thorium creates far less long-lasting radioactive waste. Uranium reactor waste remains dangerously radioactive for thousands of years, creating nightmares for storage and disposal. Future generations shouldn't inherit our toxic leftovers. Thorium is also 3 to 4 times more abundant on Earth than uranium. For India, this is game-changing because we have mountains of thorium but barely any uranium. Using thorium means energy independence, not relying on imports. There's even a security benefit. Thorium fuel cycles make it extremely difficult to produce weapons-grade materials, which is why the international community sees it as a safer option. However, thorium reactors do need a small amount of uranium or plutonium to kickstart operations, whereas uranium reactors can begin more easily. If thorium is so wonderful, why haven't we been using it all along? The answer lies in technological complexity and our nuclear journey. India recognized thorium's potential way back in the 1950s. Our brilliant scientist, Dr. Homi Bhabha, created a 3-stage master plan. Stage 1 used natural uranium in heavy water reactors, which we operate today. Stage 2 involved building fast breeder reactors using plutonium waste from Stage 1. Here's where it gets fascinating. Fast breeder reactors are like magic lamps that create more fuel than they consume. While producing electricity, they convert non-fuel material into new fuel. Imagine a car that somehow makes more petrol while driving. This ingenious process stretches our limited uranium much further. Stage 3 envisioned using thorium with fuel from Stage 2 to generate massive amounts of clean energy. We're still working on completing stage 2. The technology for large-scale thorium reactors needs extensive research, testing, and validation. India has tested thorium in small experimental setups and designed an advanced heavy water reactor that can use thorium, but no full-sized commercial plant operates yet. Building nuclear facilities takes years of rigorous safety checks and government approvals. Globally, no large commercial thorium plants exist anywhere. Over 400 nuclear plants worldwide run on uranium. However, progress is happening. China recently started a small experimental thorium reactor in its deserts and plans bigger ones. India and China now lead global thorium research. Maharashtra's ambitious plan could make India among the first nations to operate real commercial thorium reactors. This means cleaner energy fighting climate change, affordable electricity for millions, and using our own abundant resources instead of depending on others. For a country with India's massive energy needs and environmental challenges, this bold step toward a sustainable future isn't just smart. It's absolutely necessary. Thanks for tuning in to this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.